These are all curves. This is a line, a polyline. That's also a polyline. That's called a freeform curve. That's another freeform curve. Circle, ellipse, arc, rectangle. The type of object these are in Rhino is a curve. So curves can be either open or closed. This is an open polyline. This is a closed polyline. That's an open freeform curve. That's a closed freeform curve. These two here are closed, open and open. So if you select a curve, it'll say it up in the properties, open, closed. So a curve is like a piece of wire. It can be straightened like that, or like that, or you can curve the piece of wire. So all closed curves have a seam. So if I create a closed curve, that's where the seam is, and you can snap to the seam. I've got the end snap on, so that's the seam right there. Can't snap to any other endpoint but there. When you create a circle, because my mouse cursor's down there, that's where the seam will be. So if you're trying to create a closed curve, it's not quite closed like that. You're trying to figure out how to turn it into a closed curve because it says it's an open curve. There's a command called show ends. So what that'll do is show the curve start and the end. So curves are either planar or non-planar. These curves here are all planar. Planar curve means that it's a 2D curve. It's on a 2D plane. So you can pick up these curves and move it around, rotate it. It's still a planar curve though. It's still on a plane. So curves can also be non-planar. If I take this curve here, as soon as I pull one of its points up like that, that is no longer a planar curve. That's a non-planar curve. That's a 3D curve. So that is a non-planar freeform closed curve. So all curves are created by two things: the control points and the degree of curvature. Control points are easy. That's a control point, that's a control point, that's a control point, and that's a control point. So in Rhino version 6, when you select a curve, the control points will automatically turn on of that curve. If you're using an older version of Rhino, that won't happen. You can turn the points on by the points on command, and then turn them off by the points off command. So that's a control point, that's a control point, that's a control point. There. So the second thing that determines a curve is its degree of curvature. This is a degree 1 curve. Degree 1 means that it travels in a straight line from control point to control point. This here is obviously not a degree 1. This is called a degree 3 curve. What happens in a degree 3 curve is that the points get averaged out between the control points. They get interpolated. So there's also degree 2. Degree 2 is used for circles and arcs. That's a degree 2 and that's a degree 2. You can use a degree 2 curve for a freeform curve like this. It's not quite as smooth. Degree 2 isn't quite as smooth as a degree 3. And at any time you want to create a smooth free-flowing curve, you're better off using a degree 3 curve. And these here, they're all degree 3. They're all degree 1. Different ways of doing a degree 1 curve. So there is really complicated maths going on here to define this curve. And that maths is called NURBS, which stands for non-uniform rational B-splines. All CAD is based on some form of maths. It's mathematics in the field of geometry. It's basically how is geometry defined and created. And the most common type of maths you'll see CAD being used for industrial design is NURBS. That's what this is. And one of the strengths of NURBS is that it's incredibly accurate. Every point along here is mathematically calculated and it's extremely accurate. So you can edit curves by editing the control points. You can move the control points around. You can also delete control points if you select it and delete it. You can insert new control points by going edit, control points. Insert control point. So you can select where you want to insert it, there, and there, and there, and there, if you wanted to create more detail in a particular area. You can also change the degree of a curve by using the rebuild command. I select this curve and type in the command rebuild. So what's going on here is it's the point count. So the current point count of this curve is 11, and the current degree of curvature of this curve is degree 3. So we can change both the point count and the degree. Let's leave the degree the same, but let's change the control point to 30. So what will happen is it takes that curve and divides it into equal segments and creates 30 control points. The curve will change slightly. It says maximum deviation 3.8 mil, and it shows you where it is in red. So obviously the higher the control point count, the less the deviation. So let's just rebuild the curve. So I can rebuild it again. Just 7 control points. I'll rebuild it again, but this time I'll change it to a degree 1 curve. That's now a degree 1 curve. rebuild it again, change it to degree 2. So degree 2 curves aren't quite as smooth as degree 3. You can join curves together by using the join command. That one. So that's now joined them together. You can use the explode command to explode it into its individual segments. You can also use the trim command to trim a segment off. So trim. You can also use the split command type in split, select objects to split, select cutting objects, just split it. I can join them back together with the join command. Just one more thing in terms of seams. When you have a curve and the seam is here, when you offset a curve, it will offset the seam perpendicular. So the seam has been offset.